Welcome everybody. We will give a moment for people to join our webinar and we will start soon. Okay, I believe we can start our webinar. For those who will join later on, there will be also recording shared after the webinar so that you can always get things which you have missed. Welcome everybody once again on our webinar. Today's topic is infrastructure that thinks, turning static sites into smart environments with LiDAR perception. And my name is Dariusz Kominiak. I'm working in FlashEye and working with LiDAR and LiDAR perception software on a daily basis. Agenda for today, we will talk about LiDAR beyond automotive. We will talk about why infrastructure needs perception and how stationary LiDAR works in the infrastructure. Also, we will bring few of real-world use cases, and we will end up with our take on future of the environmental intelligence. And at the end, if you will have any questions, you can always contact us over the email and ask them, and we will get back to you as soon as possible. So I believe majority of us are aware of new technology in the vehicles right now, in all the cars around, which are equipped with different kinds of radars, with different kinds of LiDARs, cameras, and so on, which are great for obstacle detection, detecting anomalies, and all the ADAS systems. And that's a great use of this technology, but it is not only the use, only the place where such a technology can be used. Sorry. Right now, all those sensors are also used in robotics in a variety of applications. But what if we start to use those sensors and apply them into the environments like cities or sites, companies where they are manufacturing companies and so on? Also, you can imagine your roads, bridges, or tunnels knowing what is happening around them. We change the perspective. We are no longer seeing the world as a unit from the car, but as a global thing, which can be optimized and adjusted accordingly of what happens at the real time. We see this change already in some of the industries. We see more and more sensors, and in logistics, industry is deploying more and more autonomous vehicles moving on their own along the sides, monitoring infrastructure along the highways and some smart parking management and so on. and also more and more popular in security and people area, for example, as a perimeter protection or people counting at the events and trade shows. And I believe majority of you have somewhere seen a 3D LiDAR data and might think, yes, this is nothing novel right now. And data as it is, of course, it is novel. It is not novel. It was used for a long time for city mapping, for temporary, like one-time measurement or making 3D models of the city or of the space. But you have to remember that this is a single scan. It is done at such a point of time, and no adaptation, no real-time measurements is happening on it. It requires human intervention, scanning, analysis, and interpretation, and it is great for planning, for construction, for management, and so on. But as I said, scanning is done at a single time instance and not updated so often. And today we will be talking about real-time measurements and real-time data analytics. Why infrastructure needs perception? Basically like robotics, but from the other way around, from the other perspective. And here on this diagram, you can see different perspective from the infrastructure perception, robots and self-driving vehicles, and also human. And we name a couple of important parts like autonomous detection and action, where in infrastructure perception and in robotics and self-driving vehicles, you do have this feature. Some of the autonomous detection and action you will have in the human, in the people, when they are trained, when they are used to such things, some things, they can react on let's say automatic way, but you need proper and special training for doing that. Reduce human error, and this is something which infrastructure perception and self-driving vehicles are made for, to eliminate any potential error from the human side. City side KPIs, safety and traffic. And now we are entering the area where infrastructure perception is outstanding, because as I mentioned before, self-driving vehicles or robots, they are great with what they are doing, what they are used to do. They see their environment around them and only this, where there is no global communication, there is no global interaction and global awareness what is happening. There is no global planning of, for example, route because of the traffic and so on and so on. So this infrastructure perception in this particular case will make it even more powerful use case. Bird's perspective, to have the information, what is happening in every place at the same time. Sometimes this data might be a bit overwhelming if you look on the raw data, but this is what we talk about metadata analytics and so on, where only important data or important events are shown to the operators or to the management. And if everything is working as it's supposed to, this is not obstructing attention of the operator. Single source of truth, and this is something which I believe sooner will be very important when we have autonomous vehicles on the streets. And imagine accident of autonomous vehicles, which one was right and why it was right and so on. When we have global perception navigating all, giving information to all the vehicles around, such accidents will be eliminated because of the total awareness. And also learning the specific environment. based on where such perception is deployed, it can learn environment, it can understand patterns, it can produce information which is useful for specific environment. How stationary LiDAR works in the infrastructure. So just as a brief information, what is needed and how the setup looks like. So basically, you need a hardware setup. This is what you can see on the left side of the slide. You have sensors which are installed like standard hardware, like CCTV cameras and so on. The LiDARs which can cover large areas and can monitor at the same time ground, air, and water. Then there is no issue with any reflections or any materials which are causing disturbance on the LiDAR data. And once you have this hardware setup, the part is what is needed is a LiDAR sensors. And also all the processing, the idea, what we are bringing to you is to have local processing units. So the data is processed locally and only exchange of information happens on the metadata level, because those are the gigabytes of the data, and to transfer it is completely unnecessary. You can have a small computer next to the LiDAR which do all the processing and share only important metadata or information which is necessary from this kind of application. Perception software that unifies all 3D data. That's something which we can help you with, something which you can connect completely different 3D LiDARs from different brands, from different hardware specification, which is great because you can combine the system, you can create a system which combines all the best from different brands or from different models, from different features into one system and get this seamless integration. And on top of that, integration with other real-time and historical data. So you can combine data from different sensors, from different systems. You can share a metadata from the LiDAR 3D perception with another systems and get much better overview and more insight and more information from this data all together, combining spatial data with, for example, access system, giving you information that person has entered area and you have authorized person over there, but the 3D system can detect as well another person, combining the information from the entrance system that there was only one person authorized. You can immediately get information that there is someone unauthorized entering the area with a person which is authorized, and bring awareness to the security guards or to the proper operators. And again, a little bit how it works. This is something which I mentioned already. First, we are starting with raw data, millions of points per second. Some of the LiDARs are producing as much as like 6 to 7 million points per second. And then perception software, which can handle such a big amount of data in real time, can classify objects, can measure dimensions, providing velocity, indicate entrance to a specific zone, and so on and so on. And on top of that, integrated data, something which can be put together with other systems on a metadata level, because as I mentioned, not point cloud level of the data is not even necessary for majority of the cases, but it helps together with perception to get very good integrated data altogether. Spatial data of physical world is the enabler, and this is something which we are saying already, and we will keep repeating, that infrastructure does not collect data anymore. It sends, it interprets and acts. And that's what we call environmental intelligence. So it is not only 0-1 information, it is more information. If, for example, someone has entered some area, from which direction, with which speed, and so on, you are getting much more than only someone is there. And every second and learning over time perception insights, which can help to answer you a question, is this normal? And get more information about what is moving in the scene. If this is a person walking there, if there is a, like animal or vehicle. It also helps to automate countermeasures or alarm operators in a proper time. And something is physically changing in the scene and should be looked up. Also, you might specify different levels of incidents and get proper reporting for that, which is like automatically classified events and focus on the crucial ones. It will help operators and to focus on the most important things, and basically things which are selected as a common or not important will be properly ignored. How autonomous monitoring affects the people. And this is something which we believe is the most important, to show that it is not eliminating the people from the loop. It is just giving them the most important information which they have to focus right now. And they don't have to focus on all the other typical and usual cases which are happening all the time. And what is the most important, in our opinion, is to early detect of necessary actions. So to avoid accidents, disasters, and breakdowns ahead of time, whenever, for example, something might happen, to take action to not happen. Also, those systems will help to focus on the right things, like the spatial total control help the operators to sort information and take better decisions, because they can focus on only the most important information. Radical safety enhancement. People can work from safer distances and being discovered if they are in problems or health issues. And this can be as important as someone is falling down, and the system, spatial 3D system, will pick it up almost right away and alarm proper operator. See and understand more, and this is about utilizing the data of all physical activities, help the people to understand and improve the operations in a new level. And of course, for example, in the cities, it means better safety, smoother traffic flows, and better citizen experience, where you can avoid all the traffic, you can get directed in the places with no traffic and get smoother experience of traveling or commuting, and so on and so on. But the question usually is, where do I start? And we hear that from our customers that, yes, you have this great LiDAR system, but what should I do to actually, do I really need it, and how it can be implemented in my site? And then we always say the first step is to understand the problem you want to control. What is your problem? What is your objective? How you see it right now, and what can be done to automate or help detecting early issues and early problems. Also, very important thing is to list scenarios and incident levels, something which is natural for this use case, something which is not natural but not dangerous, and also something which is critical to detect right away and inform right now, right away, with highest alert level. And then the last part is to create zones and logics in three-dimensional space, plus integrated to already existing systems into the organization. All those three steps are necessary to get as best experience as possible and as useful information as possible. And we like to bring a couple of real-world use cases, and one of our partners is a company from Germany, and those are experts in digital solutions, and they are focusing on transforming complex physical environments into intelligent, data-driven operations. And as example, we have water treatment facility where it is hosting over 100 people a day. It is receiving over 250 daily deliveries, and all of that is happening with help of only 20 sensors which are monitoring a space. In this kind of situation, traditional systems are not able to reliably interpret what is happening across the site in real time. And currently, the goal has shifted from simply detecting activity to understand the context and identify early deviations from normal operations. And here I will have a short video how this can be done. It's a big space with water treatment facility and the system which is detecting the people walking in places. It can notify if those people are in places they're supposed to be. It can send warnings if they are getting too close to the dangerous areas, or if they can be informed right away if they should not be in such a place. And just to mention, all this data is shown from only a single sensor, so you can see a capability of current technology that only with one LiDAR you can cover a big space and you can get great insights from what is happening in such a big area. Detecting social and engineering subtle threats. This is something which also is extremely important to understand, that many incidents aren't just forced intrusions. They are behaviors that look almost like normal. For example, tailgating when someone is going through the entrance just behind the proper personnel, or personnel in wrong zones, or people taking too long time than usual in such areas, or vehicles arriving off the schedule. In such situation, LiDAR-based perception and behavioral classification flags those deviations early, so the operator can contact or can notify proper people at the facility and get action before something will happen. Operators gain situation awareness before incident, and they are enabled for faster and more appropriate responses. Also, those spatial 3D perception systems, they are aware of animals and vegetation, so something which you typically slowly start to affect other systems will not cause any problems in those spatial aware 3D systems. Another example are intelligent zones. And here we are talking about number of anomalies based on predefined scenarios. So this is what I mentioned before. Extremely important is to list those scenarios, list what is the typical case, what is not typical case, what is a dangerous case. And so the system will act accordingly to your specification. Matching activities towards the operational data. This is something which is done behind the, let's call it behind the curtains, and only not normal data is presented to the operator. Activation of spotlights and alert systems, which can be done completely automatically based on the detection and based on detection in specific zone. And all those will lead to reduce and resource and operation optimization, and also enhance security and enhance safety, which overall is a benefit for every of us. Connecting sensor to operational true. This is something which is done on much higher level. And we are talking here about detecting done by perception, 3D perception, and then connecting with another systems, for example, logistics system, personal database, or operational schedules. The platform can verify, does this delivery match with today's manifest? Is this person authorized in this zone right now? Is this traffic pattern normal for this time of the day? And the system can understand those behaviors, those if this match the usual case or not, and bring awareness to the operator. And this is what is most important. Time-aware intelligence highlights meaningful anomalies while reducing unnecessary alerts that burden operators. So the operators can focus only on the most important and most urgent things to resolve. Moreover, those systems can provide 3D signatures. Is this vehicle normal in type, size, and time? All this kind of metadata can be now accessed and can be utilized together with other systems at the same time, other information, as I mentioned, personal database, operational schedules, and so on. Another important thing is personal safety and lone worker protection. Same hardware, same sensors, same perception system that handles security also is able to monitor personal safety in remote and hazardous zones. So you are getting basically many benefits at the same time: safety, information, and security, and also more insights if everything is accordingly to the safety standards. System can detect a person motionless in a danger zone or unauthorized zone entry, or behavior diverging from expected patterns. And this is something which I believe many facilities would benefit from, that only one deployment supports security, safety, and operational efficiency, where with a quality monitoring at the same time. And this is what we see as a future of environmental intelligence. As a whole site or city or indoor is covered within a spatial data, it allows to see everything and react on risks, potential accidents before they occur, and being more proactive than ever before. Autonomous decisions making at the edge, where environments will sense and act, and distributed edge systems will trigger actions without waiting for cloud processing, which will enable faster safety responses and self-optimizing operations. Large-scale utilization of physical AI, where physical AI will let autonomous systems perceive, understand, and perform complex actions in the physical world. 3D perception is a key enabler here. Predictive and self-healing environments, and by combining continuous spatial sensing with machine learning models, sites and cities will predict failures and security risks or maintenance need and adjust automatically before disruption occurs. And several points which can be right away addressed with our perception software. Since you are here, you most likely heard about our flash-eye perception, which is utilizing 3D LiDAR data, where you can aggregate multiple LiDARs, as I mentioned before, from different models to different brands at the same time in the same system. The system which can perform object classification, object detection, monitoring, and change detection. We are working with advanced filtering from as simple as snowflake filtering from the snowfall to have advanced filters for vegetation growing in the field of view of the sensor, for advanced filters to get best and most accurate measurements for traffic monitoring and so on. Everything is container-based software with low CPU requirements, so you can even find sensors with running our software directly on them on the market. And you can create 3D zones in the areas which are the most critical, the most interesting for you to detect and react on, together with integrations where you can get metadata to the system you already use and interpret in a right way. So basically, our software will provide you with all perception modules you need to interpret 3D data and integrate to already existing platforms like security, like even PLC control for the factories, and so on and so on. And with that, I would like to thank you for your attention. You can follow us on the LinkedIn. You can contact us through the email address if you would like to learn more, if you'd like to get in touch with us. And with that, I would like to thank you for your attention today and hopefully see you next time.